Hey there! Today we're going to build a little program together, and I'll show you a few tricks for how to make it more testable. We'll be covering concepts like side effects, factoring code into functions, abstracting code behind interfaces, and dependency injection. And I'll assume that you have a little bit of software engineering knowledge. Let's go! Here's what the program is going to do. It's going to take two file names from the command line, and it's going to read the first file passed in, compute the number of words in that file that show up more than once, and output that number to the second file. So let's code this. I'm using TypeScript for this demo, but the principles I'm showing here can work in any language. If you aren't familiar with TypeScript, that's okay. It should still be reasonably readable. I'm going to speed it up a little so it's not too boring, but you should still be able to follow along. First, we're going to check to make sure the user passes the right number of arguments in, which is 4. The first two are the node executable and the script, so the ones we actually care about are index 2 and 3. So let's assign them to variables. Then we'll read the input file into a string. Oh, and add the relevant import along the way. We need to split the input data by new line, and then split each line into words. And then filter out the empty words. After all this, the words variable contains each word in the input file. Now, for the algorithm, we can create two sets, one that contains words that we've already seen, and one that contains words that have been repeated. As we process each word, we check to see if we've seen it before. And if we have, then it's repeated and should be added to the repeated set. And then we mark it as seen. Finally, we write the result to the output file. Not too bad. Okay, let's try it out. I have some sample input here that's from the Wikipedia article on unit testing. There should be 3 repeated words: computer, testing, and of. Okay, looks like it works. So if we want to automate this test, we could write some code that runs the script on this input and verifies that the output file contains 3, and I won't show that code here. This approach definitely works, but let's say we want a test that doesn't touch the file system. Tests that don't touch the file system or make network calls are generally much easier to run because you don't have to involve those components in the test. If you're working on a complex project or service, it might be talking to a database, other services, the broader internet, or reading and writing from the file system. Including them all as part of the test usually ends up being fragile, slow, and expensive, which is why removing them from the test is a great idea. How do we do that? One starting point is to separate the file system and non-file system parts by moving all the non-file system parts to a function. If we write tests that call that function, we'll be able to skip all the file system parts. Let's give this a shot. We'll call our new function numRepeatedWords, and it'll take the input file string and return the number of repeated words. That way, reading the input and writing the output will be outside of the function. Then we just need to copy the computational code into the function and rejigger a few bits to make it work. After that, we can delete the old code and call the function instead. We'll also have to use this if statement to ensure that this section of the code only runs if this file is being executed from the command line, which is what I was doing earlier. If the file is being imported as a library, which will happen when we test it, we don't want this part of the code to run. Now, the program has been split into two pieces, the part that touches the file system here, and the part that doesn't touch the file system, which is the numRepeatedWords function here. This numRepeatedWords function is super easy to test because it doesn't do things like accessing the file system, making network calls, or accessing global variables. In computer science lingo, we call these kinds of functions pure functions and say that they have no side effects. Common side effects include accessing the file system, making network calls, reading or writing global variables, accessing the current time, and using a random number generator. Ask your doctor for more details. Just kidding. Anyways, pure functions are wonderful because they're so easy to test. Let's pop over to our unit testing file and start writing tests in it. I'm using Mocha, a test runner, and Chai, an assertion library. We'll define one test, and inside of it call num-repeated words with a few different test strings, making sure that the result is what we expect. We'll do a few simple cases and a few slightly more complicated cases. By separating out all the side effects, testing the logic is as easy as a function call. Let's remember that as rule of thumb number 1. Make code easier to test by removing or isolating side effects. We'll look at another way to isolate side effects right after this. Alright, we can now run the test, and it passes. Unfortunately, there are parts that aren't being tested, namely everything outside of the num-repeated words function. For example, we aren't testing that the results are being written correctly. If I accidentally delete this line, which writes the output file, the test will pass, but the program is wrong. How do we catch that? We can use another fancier technique to isolate side effects, which is called abstraction. We can think of the app as being composed of two modules, the main module plus the Filesystem access module. The general flow is that the main module says, "Hey, Filesystem, read this file," and the Filesystem module says, "Sure," and gives you the contents. Then we run the num-repeated words function to get the result, and then we say to the Filesystem module again, "Hey, write to this file," and the module does it. In actual code, these commands are just function calls, but I'm talking about it this way for a specific reason. You can think of the commands as a contract between the main module and the Filesystem module, which is that if the main module says, "Do X," the Filesystem module will do it and return Y. For example, if you ask me to read a file, I will return a string. This is important because if two modules have the same interface, then they can be freely swapped around with almost no code changes. I can make a new Filesystem access module that has the same contract but does something entirely different. This allows me to customize the behavior without having to rewrite big parts of my program, which is really helpful for testing. For example, I can make a new module that always returns trololo when asked to read a file. It might sound useless, but modules like that are really helpful for testing. We'll code one in just a second. You'll find examples of this module swapping pattern everywhere in life, like how you can unplug a microphone from a USB socket and plug in a keyboard because they both are USB devices. You can pop out the ink cartridge of a printer and put in a different cartridge, as long as it has the same shape. You can eject a game from your game console and put in a different one because they have the same CD shape. In our specific case, we can create an interface that represents access to the file system and supports two operations, reading a file and writing a file, because those are the things we need to do in this program. Then we can build two implementing modules. One is a real version that actually accesses the file system and will be used in the real program. Another is a fake version that we can swap in order to write tests. Let's code the interface now so you can see the two operations. We'll call it the file system interface and give it two functions for the two operations. The first one is readFile, and we'll take the file name as a string and return the contents as a string. The second is writeFile, which will take the file name and the content as strings and return void. Then, we'll build our first implementing module for this interface, which will actually access the file system. This is the one that the script will use. You can see that TypeScript is complaining that the object is invalid because it's missing the proper definitions, which we need to fill in, so let's do that now. It's fairly easy to write because you can call the original file system methods with not much modification. Then, we'll fix the rest of the code to use our interface. Let's start by importing the right stuff from the other file. Then, I'll move this part of the code into a run function that accepts a file system interface and the two file name arguments. I'm doing this so that we can change the arguments depending on what mode we're in. When we run it in real mode, we'll call it with the real file system module and the command line arguments from process.argv. And when we run it in test later, we'll pass in a test module and fake arguments. The run function is still directly calling fs.readFileSync, but we want to use our new file system interface methods, so we need to change those calls to use their interface instead. The net result is that whoever calls run can customize the file system behavior by changing the file system interface that's being passed in, just like we talked about earlier. If you call run with the real module, the file system that read file and write file methods will do the real thing. If you call it with the test module, it'll do something different. This is how we're able to customize the behavior of the run function without having to change any code in the run function. Since we're coding the real mode right now, let's pass in the real module and the arguments from process.argv. Okay, let's just make sure the program still runs. Great, looks like it's still working. Now, let's write a test that uses this new run function. We'll need to make the test module I talked about earlier. Because it's a test module, everything will be faked, and we'll be adding lots of test expectations to make sure things are going right. Before we implement the module though, let's set up the run call. The first argument is the module, the second argument is the input file name, which we can pass a fake string for, and the third argument is the output file name, which we'll also fake. Now, for implementing the module's read file, we want to make sure that the file name that is asked for is the same as the first argument, since the program should read from the first argument passed. This assertion would catch if we accidentally messed up the input file name in some way. Then we'll return some fake contents. For write file, we'll make sure that the output file name matches in the same way, and we'll make sure that the contents to be written are what we expect. Finally, we want to make sure each function is called exactly once, because if they aren't called, something is probably wrong. We'll keep a call count for each function and assert that they're both 1 at the bottom of the function. Great, let's run this test. And it passes. Now, if we mess up the file system part of the code, the test will fail and we'll be notified. Let's deliberately make a bug by accidentally writing to the input file instead of the output file, which is a copy and paste mistake that could actually happen. Let's run the test now, and it fails, and helpfully tells us that it was expecting the output file but actually received the input file name. We're able to verify that the program is making the right calls to the file system, even though we are not actually even writing to the file system. That's the magic of abstraction. To summarize, abstraction is a great way to customize the behavior of parts of your program without having to recode them. If your code is performing a function that's not behind an interface, that functionality is called tightly coupled to that part of the code because it's hard to customize. In our example, the file system handling was tightly coupled. By extracting that functionality to a separate module, we gain the ability to customize it by writing different modules that implement the same interface. This is useful not just for testing, but also for making code more flexible in general. For our specific case, it allows us to isolate, override, and test side effects. This idea also goes by a fancier name called dependency injection, which you may have heard about before. Remember our rule of thumb number 1. Make code easier to test by removing or isolating side effects. And let's add our rule of thumb number 2. Use abstraction or dependency injection to encapsulate side effects so that you can write mock implementations for testing. Let me finish by saying that the program we wrote today was really simple, so using all the techniques I covered just now to test it would be a little bit excessive in real life. I just wanted to demonstrate some testing techniques that will be incredibly valuable on real larger projects that you'll encounter in your life. For more info on this, check out the video description for a link to my blog post on how to think about testing. Thanks for watching. If you enjoyed this video, please share this with someone who'd enjoy it too. Thanks for watching. If you enjoyed this video, please share this with someone who'd enjoy it too.